This is section 9.4, geometric sequences. Okay, they say a sequence is a geometric sequence if the ratios of consecutive terms are the same. Okay, if you remember ratios, it's when you're comparing one number to another. And here, this with a ratio, they're saying take the following term and divide it by the previous term. Okay, so we have a sub 2 divided by a sub 1. That's going to give you an r. It should be the same if you take a sub 3 and divide it by a sub 2, or a sub 4 divided by a sub 3, so on and so forth. R cannot be 0. You cannot have a common ratio or a ratio of 0. Okay? It can be written in the form a, or a, and then a times r, then a times r squared, and so on. So, for example, let's say I have my r is 2, and my first term we're going to say is 3. So I'd have 3, and my next term would be 3 times 2, which would be 6. My next term would be 3 times 2 squared, which is 4, so I get 12. The next term would be 3 times 2 cubed, which is 8. 8 times 3 is 24. Okay, you can see that when you divide each term, so 24 divided by 12, I get 2. 12 divided by 6, I get 2. 6 divided by 3, I get 2. Those are your common ratios. Okay, so the number r is called the common ratio of the sequence. Each term in a geometric sequence can be obtained recursively from its previous term, preceding term, by multiplying by r. Okay, so you take the term that was before your original term and you multiply it by r. That's for all n's that are greater than or equal to 2. Okay, well, that was recursively. Explicitly, we can define the sequence as a sub n equals your first term, which is your a sub 1, times your common ratio, which is r, raised to the power of n minus 1. All right, so let's try defining some geometric sequences. Okay, here they're asking us to find the common ratio, find the 8th term, write a recursive rule for the nth term, and write an explicit rule for the nth term. Okay, so finding my common ratio. We said you find your r by taking your ending term and dividing it by the previous term. So let's say I have 24 divided by 12. That's going to give you 2. If I do 12 divided by 6, that's going to give you 2. Okay, so here your r comes out to be 2. Your common ratio is 2. All right, so now we need to find the 8th term. If I look at the 8th term, I'm going to say I have a sub 8 is equal to my first term times my common ratio raised to the power of 8 minus 1. Okay, so a sub 8 is equal to my first term. My first term was 3. I'm going to multiply that by my common ratio, which is 2, raised to the 7th power. Okay, so that works out to be 3 times 128, which is 384. Okay, next I need to write a recursive rule. In order for me to write a recursive rule, I need to start off with my a sub 1. Okay, a sub 1, which is my first term, is 3. Okay, and then when you write your recursive rule, I'm going to say and my a sub n is equal to my previous term, which is a sub n minus 1, times my r, and r here was 2. You can rewrite this another way, so I could say or a sub n equals, and move your 2 out in front, 2 times your a sub n minus 1. Either way is fine. Lastly, we have to write an explicit rule. Okay, on the explicit rule, it says you take a sub n is equal to your first term, so your a sub 1, which was 3, and you're going to multiply that by your common ratio, which is 2 raised to the power of n minus 1. Okay, so this is your explicit rule. Go ahead and pause the video for a moment and try the problem that you have at the bottom with 3, 15, 75, and 375. And when you're done, unpause the video to see if you've done this correctly. Okay, this concludes the videos for geometric sequences.